Hello, welcome back to my channel. Today I wanted to show you guys how to do this effect, which is a new 3D Mesh Flipbook technique I developed for High on Life 2. I was looking for a way to have liquid splashes with changing topology that supports interpolation and slow motion to do some like head exploding blood splashes, water splashes, slime, stuff like that. But also I wanted it to be lightweight, so like no VATs and no alembics. So I actually developed a technique that has a vertex color that I use to push vertices between the frames. And surprisingly, all those splashes that you see right now are less than 1 megabyte, so it's very optimized for memory. Let's see, if I bring down speed, you can see that it supports slow motion. And yeah, let's jump right in. Alright, so the first part is obviously to generate your splash. So for me, I just took like a liquid gen demo scene and modified it until it looked exactly like I wanted. So for this example, I'm just gonna take this one, which is called Splat Game Flipbook Liquid Gen. This one is perfectly fine. So the only thing you have to do in Liquid Gen is to drop a string here and add an export particles. So alembic is what you want, main liquid, 64 frames is fine. Just fill this out however you want and export. Just a quick note from the future, I've spoken with the Liquid Gen guys and they told me that they are working on a way to automate all the steps I'm about to show in Houdini so that you're gonna be able to do all of them directly inside Liquid Gen. You're simply gonna do export to Unreal or something and all those steps will be done automatically. So I might do a new video when that comes out, but for now we have to do it manually inside Houdini. Cool, so now in Houdini, import your alembic. It's gonna look like this, particles. So what the first step is to convert it, because if I middle click on this, it says 1.1 primitive. That's not what I want. I want to have access to all these properties. So you drop a convert, then you have access to all your points, all the properties. And what is the most important thing is the ID. So you've got velocity, point position, and ID. ID is really important because I'm going to transfer properties from one point to the same point on the next frame via its ID. So the next thing you want to do is to put a time shift. So you input a $F+1 to get the next frame, and next you put an attribute copy. And what you're gonna do is match attribute ID. So you want to copy attributes from this set of points on this set of points if the ID match on all the points. So you match by ID. What is the attribute you want to copy? Position, and we rename it to next position. So on this set of points, if I look here, I have the current position and the position of the same point, but on the next frame, which is really important. So the next step is to calculate the difference between the current position and the next one and store that information in the color of the point. So basically just create a attribute VUP, which I called calculate delta to next position. And real quick to recreate it, like basically the nodes are called mix, and you put color, or yeah, 3 vector. You put your position in the first input, then you do bind like this. You type in next position, place that here in the second input, like this, and then you place that in the position. That will be useful to basically preview if it works or not. So once you have your mix like this, the bias, you can middle click on bias and do promote parameter, and then if you click on it and name the label I don't know, the interpolation bias is pretty good, exactly like I did here. If you go back and look at the scene view, you have a control here called interpolation bias. So if you move that from 0 to 1, you basically have all your points moving from their current position to the next, just with that control. It's just a way to visualize it if it works. And so in the color, what you're gonna want to do is put a subtract node. Just subtract the current position, the next position from the current position, and you can do a bind export and call it delta to next position, and the type is vector. So you create that, and don't forget to plug it in the color. It should look like this. So this is a color representation of what all the points need to do to reach the next frame. This is how I'm gonna interpolate the position in Unreal, because on the mesh further down, I'm meshing all of this, and I'm gonna bring the color on the mesh directly as vertex colors. And in Unreal, I'm gonna be able to push the mesh to the next frame, basically. Cool. The next step is to delete the points over time, because in LiquidGen I don't have that much control on when I want my points to be deleted, so I thought it would be easier to do it in Houdini. So basically, if you look here, I had 2 keyframes and my points are going bye-bye, like this. So just put the attribute Rango, and you can type in float percentage equal CHF threshold, or whatever you want to call it. If I copy paste this, you can do if a rand at ID is lower than percentage, then remove point. So this will delete all the points that are lower than the value of threshold. So if you put Rango, I just want to show you something. If you paste this here, you won't have the control yet. You have to click on this button and then threshold happens. So basically, you can see all the points being deleted. And let's say I want to delete them from frame 10. I could shift click threshold. I think it's alt click to do a keyframe. So 0% on frame 10, and I want all of them gone by frame 20. So I'm gonna put 1, alt click. And if you shift click, you can tweak your values here. So this is how I do this. Perfect. So right after that, I'm gonna mesh all of this. So basically, there's nothing special about this meshing. Just particle fluid surface, it's called. And then, whoops. You plug this and you tweak all the values. For me, it was those values, but it's probably going to be different for you. You just like tweak them until they look good. I don't have any filtering on, nothing special in regions or filtering, just surfacing. And I think the only thing that is important is that you convert them to surface polygons and you keep those attributes. So I want to keep velocity and delta to next position. So what this does is taking the particles that are coming in and transferring them to the mesh. So if I look at geometry spreadsheet, you can see I keep my delta to next position and velocity. The very next node is a time shift. I'm just advancing everything 1 frame, and you're gonna see why. If I don't, I have kind of this poop at the beginning, which I don't like. So I just added the time shift, so it starts on frame 2, essentially. And okay, the next step will be to delete the small droplets, because they add a lot of polygons for no real visual benefit. You don't really see it in Unreal. So I'm gonna keep only the big chunks. So the way I did that, this is a subnetwork, but like you can do it just by creating some standard nodes. You don't have to subnetwork it. It's just because I copy pasted it from another setup. But essentially, you start by put a connectivity, and you change points from primitive, So this is what I have here, and then you put a measure node. And then you put the piece attribute class. So I'm gonna measure every separate polygon islands because they all have a class, a name different on each of them. So the piece, so I'm measuring by piece with the name class. And if you look at how it looks on the geometry spreadsheet, you go on the primitive, you can see that it measures the area per class. So class 0 is 0.2. If I go down, class 37 is 166. Class 61 is 804. So this will allow me to delete the small pieces only and keep the big ones. So just put an attribute triangle below it, and just like we did before, you put the threshold. If area is smaller than threshold, remove prim, blah blah blah. Put yourself on primitive, and this way, you see, I can. If I go a little bit further, I can see what it does. It's deleting all the little droplets, so I can concentrate on having all my polygons on big pieces. If I have them on small pieces, then I'm wasting them, essentially. So this is what this does. Like I said earlier, you can you don't have to subnetwork it. You can just do it like that. Cool. So the next few steps are really straightforward and easy. Let's start by adding a poly reduce to total poly count 1500. For me, this number works really well. I've done a bunch of tests, and even though it appears like a triangular mess, it looks really good in Unreal. I'm gonna smooth it out down the line, but yeah, feel free to change that number to something that matches your budget closely. For my experience, if you have like a 23 frames at 1500 each frame, it looks okay in Unreal. So you have room to put more, but for me it was enough. So you can put a normal just below it, so it smooths out the normal. Put a smooth to, for me it was 0.41 strength and filter quality 5, which makes it look already a bunch better. Also put the attribute wrangle to multiply the velocity. It's really simple. You put it on points, float multiplier, CHF. CHF, by the way, creates those slider controls that are really nice for attribute wrangles. So I call it V multiplier, and basically I multiply the velocity by this number. So for me, the velocity minimum and maximum is like between minus 200 and 200, so those values work really well within Unreal. It's gonna depend on the scale of your splashes. Mine is pretty big, so you know, play around with those values. Cool. The next step will be to bring all of that to 0, 0, 0. So I need to do this, and that it doesn't find the center of every mesh and center it, but rather find the center of the mesh on the first frame and move everything to that center. So to do that, again, I've done a subnetwork. You don't have to. You can create the nodes here, but I prefer to do it in a subnetwork. So first step will be to create a time shift to frame 1. So basically, oops, if I click here, I need the first frame. That will not move. You can put a extract centroid just below it. You make it run over the detail, bounding box center, output attribute, and attribute name centroid. So if I look here on detail, you can see the X, Y, and Z values of the centroid, which are those. And then you put an attribute wrangle below it on run over points, and then you input those 3 lines: vector centroid equal detail 1 centroid. So basically I'm getting this centroid value, and I'm gonna reverse it here. So I'm doing -1 to basically take this -1 gives out the center. So I'm gonna reverse it and apply it. So the position is += inverse centroid. So now that I have that, all my frames will be centered to 0, 0, 0. Next, we want to take the delta to next position and write it into the color attribute of the vertex. So as you can see, I have some values sometimes that go below 0 and over 1, which is not supported on the vertex color in Unreal. So I need to take all my values and make them fit between 0 and 1. So it's pretty easy to do this. You can do another attribute VUP like this. I called it delta to next position to vertex color, and by default you're gonna have one of those global this on the left. You can delete it, and you can do a bind, put that to vector and write delta to next position so I can get the this attribute. We're gonna put a divide node and divide it by 10, 10, 10, 10, all the axes, and then add 0.5, 0.5, 0.5. I'm gonna reverse this process in Unreal automatically, don't worry. This is just so that my color, it's a bit hard to see, but there is color on this, and if I look here, my color is now all set between 0 and 1. And so if I divide it by 10 here and multiply it by 10 in Unreal, then I get the original value. So this is what this does. Right below it, you can put a clean node and put those values in. So I'm gonna remove all the attributes, so star for all the attributes except velocity, normal, alpha, UV, and color. So just copy those parameters. So if I go here, it's gonna delete the delta to next position attribute and keep it clean, so we can move on with only what we need. All right, now here comes the most interesting part of my setup, which will take all the frames and bake them into one. So if you look here, it takes all the frames and make them one mesh, and every single frame has an alpha value between 0 and 1 depending on which frame it is. So if I have 23 frames, I take 1 divided by 23, and this is my increment on each frame. So if I look here, the alpha, I'm gonna filter it out. Okay, so alpha is 1 divided by 23, that's 0.043. So this is what you see here. My frames go like this. If you add 0.04 every time, you see I'm at 0.2, 0.3, 0.4, blah, blah, blah. And this is how I'm gonna be able to select which one is visible in Unreal. So to do all this, you do a for each number loop, like this. And for me, I had 23 frames. So you come at the end here and you put iterations 23. Like it's shown here, and then you put a time shift just below for each begin input, and this is where you're gonna put the iteration, because this is looping 23 times, right? And every time you want to time shift to freeze the frame to the current iteration. So if I go here and type detail for each count 1, so this node here, iteration is gonna reference the current iteration of the loop. So right now I'm on 22, because it started, I think, at 0 and did 23 increments, so the last one is 22. And then here is, okay, so you go and grab the total number of frames here at the end. The current frame is just like we did before, the current iteration. And then you divide the current frame plus 1 divided by total frames. That's your increment of alpha every time. So if you do this properly, you should have your alpha values set up like this. And the last frame is 0.95, the first one is 0.04, and so you should be good to go with this. We are pretty much done with the Houdini stuff. There's a few more nodes for polishing, but we're going to be moving on to Unreal really soon. So the last few nodes I had are another normal node to smooth out the normals, another smooth strength 10 for the normals again. I found those values by tinkering around and trial and error until I found something I liked. So for me, those values work really well. This is an important one. You have to invert the Z and the Y axis so that Unreal understands properly what you want. So if you put a vector to float and a float to vector, you just keep the same X and invert the two bottom values. You do that for the color and the normal. So just invert those. And then you put a clean to delete every attribute except color, alpha, and normal. You delete all the groups as well if you have them. I just figured out also a few minutes ago that I do the velocity motion blur in Unreal with the vertex color and not the velocity attribute. So you don't need velocity at all. I know that I mentioned something about velocity in the beginning of the tutorial, but you don't need it. Then you put a transform, just multiply everything by 10 because it was a little small. And in Unreal, multiplied by 10 looked good. And lastly, I put another smooth that smooths out the color. So I have a strength of 100. I believe what that does is make the interpolation smoother, because if we had some stray droplets, it was looking kind of funky, so I smoothed it out and it looked better. So at the end you can put a rough FBX and export that to a standard FBX, which would have all those values and nothing more. So if I look at the FBX I've exported, they average out like 3.5 megabytes, but then when you import them into Unreal, they will be compressed even more to like 0.8 megabytes. So let's move on to Unreal. Back in Unreal, it's pretty easy. I'm gonna take like, well, let's take all of them, 15 of them, and import them here. I'm gonna reset to defaults just to show you that it's very simple. The only thing you want to do is disable nanite. I don't think it would change much. I just don't want the geometry to change at all. So disable nanite. Next, you want to make sure that vertex color import option is set to replace, so that it will import the vertex color instead of well, not having vertex color at all. And maybe here when it says import materials, import textures, I like to untick those just because like force of habit, I guess. Let's press import. Sweet. I'm gonna place all of those here. Cool, that looks like a hot mess. Cool. Now that I have all of that, let's just create a material. Add material. It's, I don't know, let's call it m_fx double underscore mesh flipbook liquid 01. Cool. Press enter, and then the only thing you have to do is go here in the pastebin URL that I will provide in the description of the video. You click on raw here, And then you can press Ctrl A to select all, Ctrl C, Ctrl V. You should have all of these cool nodes appear. Now all you have to do is to plug base color into base color, specular, specular, roughness, opacity mask, normal, and WPO into world position offset. And the material needs to be set to masked to enable opacity mask to change. And by trial and error, I figured out that two-sided is very expensive, so don't enable that. And also, if you plug anything inside anisotropy, it becomes like a 25% more expensive for no visual difference, so leave it like this. You can press save. Let's create a material instance of this. Rename it MI for material instance, and then remove the end. Cool, so now we can apply this on all our meshes. If I click this, ta-da, you can see and by default I believe I'm in vanilla Unreal, but if I click on show here and type in blur, the motion blur is off, so that's why it's not very impressive. But like with motion blur on, you can see the movement really sells it. And one last thing I've noticed is on meshes very complicated like this one, you know, it has a lot of tendrils and shapes and stuff. You can see the triangles even more because they are spread out on all the shapes, where if you have a shape that is much more simple like this one, if I can manage to click on it, this one, as you can see, it's a lot smoother because it doesn't have that much tendrils, just like the one. So you might have to play around with the poly count on different shapes and variations of your splashes. So one last thing I wanted to show you is if I open the material instance, they are separated in categories, but if I click on animate and if I uncheck this, I have the control now to freeze time, and I have a parameter here. I have a parameter here called non-animated progression, which I can move and see myself moving. And so you can see the interpolation. You know, it's not perfect. You can see when the frame changes, but it's not static between frames like a traditional flipbook is. So if you slow down a traditional flipbook, you will see a frame repeated, another frame repeated, with no movement. With this, you know, it moves, then change, move, change, move, change. So it looks better in slow motion than traditional flipbooks. So you can see clearly the triangles I was speaking about, especially when it becomes spread out like this. If I can find a more simpler one, maybe this one. This one looks better for the same amount of polygons. So you have all the other traditional controls that you would expect, like a roughness, specular. I've put like good working values for by default. You have, the interpolation multiplier. This is in direct relation with the scale of Houdini. So if I put 100 here, it's, you know, it will interpolate way too much, which is why it goes too far and then comes back too far. If I put 1, you can see it looks stop motion a little bit. 10 is the Houdini scale, so that's why it looks perfect. But if your stuff is 10 times bigger in Houdini, maybe put 100 here instead of 10. You can increase the motion blur. Be careful with this. I think it's gonna be more expensive though. You can go too far, obviously. I think it's 1.5 by default, or no, 5. 5 looks good. One last thing you could do is put some dissolve. So, you know, what's it called again? Jitter, sorry. Jitter temporal anti-aliasing. I'm not gonna go into much detail about that, but basically when your liquid reach the end of its life, it's gonna dissolve out even though your material is opaque. This could be really useful, but I removed it from my simple master material just to keep it simple. Also, if you want to use this with particles instead of static meshes, it's really easy. Instead of this, you would put, for example, parameter, dynamic parameter. So this is to use with Niagara. You would say, I don't know, normalized age, and then plug this here. So that will control the lifespan of the age of the particles from 0 to 1. And also, I just forgot that here you have to change your total number of frames. It's set by default to 23, the same thing as in Houdini. But if you have any other frame count, change it here. So I hope this was useful, and see you next time. Thank you.